Alright, we're going to look at the Pythagorean Inequalities Theorem. So what this is going to tell us is, it's going to tell us if a triangle is acute, right, or obtuse. So an acute triangle has three angles that are less than 90. A right triangle has one angle that's equal to 90, and an obtuse triangle has one angle that is greater than 90. So we can use our Pythagorean theorem to tell us this. And so we know that a squared plus b squared equals c squared. That's a right triangle. And so when we have a triangle, and we have our A and our B and our C, and we plug our numbers into our Pythagorean theorem, that a squared plus b squared, when it equals c squared, it's a right triangle. Well, we can also use this to tell us an acute or an obtuse. The key here is that when I take my numbers and I plug them in, if my two sides are bigger than my large side, then it's an acute triangle. If my two sides are smaller than my third side, then it's an obtuse. And so you think about that, kind of makes sense. So let's just say this were A and this were B, and this side here was C. Remember that the biggest angle is always opposite the biggest side. So if you kind of apply that out a little bit, you'll realize that if these squared are bigger than this, then that means C is not quite that big, and so it's not going to be big enough to make a 90 degrees, so that's why this would be obtuse, because our third side is less than 90. Whereas over here, if our C squared is large enough to be bigger than the sum of these two, the biggest sides opposite the biggest angle, when it's greater than your two small sides, then it's obtuse. So let's look at an example. Our first example is 4, 4, 5. And so, this could be written in a lot of different ways. The first question could be just, is it a triangle? And so a lot of kids will just do, 4 plus 4 is bigger than 5, so yes, it's a triangle. And so since 8 is greater than 5, you might say, oh, it's an acute triangle. Alright, well, that doesn't tell us whether it's acute. We need to use this. That will tell us whether it's acute or not. So let's plug it in now. So the A and B don't matter. It's always, make sure you have it in order. So small, medium, large. So this will be my A, my B, and my C. So 4 squared plus 4 squared, and we'll leave this blank and do 5 squared. So 16 plus 16, we're going to compare that to 25, and so a 32 compared to 25, well, 32 is bigger than 25, so then that means that this would be an acute triangle. Okay, let's look at another example. Let's do 6, 8, 10. Again, notice, always write them in order, smallest to biggest. So again, you might be thinking, well, 6 plus 8 is greater than 10, 14 is greater than 10. All this tells us is that it's a triangle. Because look, these are basically say the same thing. The left side is bigger than the right. Well, let's go ahead and plug it in and see what happens. So I have 6 squared plus 8 squared. We're going to compare it to 10 squared. 36 plus 64. Compare it to 100. So now 36 plus 64 gives us 100. So that means that the left side is equal to the right side. So when they're equal, this is a right triangle. So here, this is an example where your logic here wouldn't work. You have to always plug it in to your Pythagorean Inequalities Theorem. Alright, the last example. Let's look at a 3, 8, 10. And so let's first just make sure it makes a triangle. 3 plus 8 is greater than 10. That's true. And so this illustrates why we can't do that. All three of these work, but they're all different triangles. So now let's plug it in. 3 squared plus 8 squared. We'll compare it to 10 squared. So 9 plus 64 compared to 100. 73 compared to 100. So 73 is less than. And so that tells us that it's obtuse. And if you think about it, it makes sense. Our third side is really big. It's bigger than the sum of these two squareds. And big means obtuse. So I hope this helps.